So let's say that I've got this trash packer right here, and I want to be able to optimize this for the smallest amount of weight and still have it be able to take a certain amount of force before failure. What can I do? Well, I can vary the gusset thickness, the gusset angle. I can vary the number of support gussets. I can vary the bottom plate thickness, perhaps something in the handle. I have all these variables that drive both the strength and the weight of this part, and optimizing all of those variables is quite a challenge. This is a video on how we can get SolidWorks to do a bunch of the work of that for us in optimizing this part by weight while still meeting a minimum amount of strength. And from here we're going to start on the top plane. We're going to make a circle and give it a diameter of 8 inches. Let's start with an 8-inch circle. We can extrude this to 0.25. Starting a sketch on this face. We'll make that, say, 3/4 of an inch. Yeah. And then we're going to extrude, let's say 2 feet 25 inches, and done. Now we can go onto the front plane, sketch from the edge to the midpoint up here and back, and then we simply give it one angle. 45 degrees will work. Extrude mid-plane, do 0.125 or 1/8 of an inch, and done. And then we can circular pattern around this direction. 5 is good, and we're done. So let's optimize this because we can vary these support gussets a lot, and we'll say we want to have the minimum amount of weight with the threshold of strength that is below the yield strength of the material. To do that, we'll need to go to our add-ins and activate simulation. That's, of course, a different license. So on the simulation tab, we can go to New Study. We'll do something like a static analysis, and we need to give this a material. ABS, and we'll indicate that the handle would be a fixed geometry. We'll make an external load as a force. We'll go English units. We'll do something like a 150-pound force on this face. And now we'll need to mesh. Oh, but I don't need the advisor. We'll create a mesh. We'll look at the parameters. Our rib width is 1/8 of an inch, so 0.150. We'll have to make that 0.1, and the smallest mesh is fine. We're currently meshing on a different monitor. There we go. Alright, so that mesh looks good. Going back now to the model, we can go to the Evaluate tab, Design Study, and Parameters, and we can say something like rib angle. And if I double click on the rib that I've created, I have to think about, there we go. We can populate this. Notice when I click on the dimension, it fills it with 45 degrees. We'll do the same thing. I can say rib number as another parameter. And when I double click, I see the number 5 because I have 5 ribs. So that'll be another parameter that we can alter. I might want to alter the thickness of my base plate. If I double click, I can see the thickness there. I can say base thickness. And then finally I might want to also alter my rib thickness. Alright, so I come in here. Here's the thickness of my rib, 0.125. So I say apply. Oh, rib thickness. Apply. Okay. From here, let's go with right-click, New Design Study. And here I've got variables, and if you look at the parameters that I just specified I can alter, I can choose my rib thickness first. And this is the parameters in which I can alter it. So I can say a range of values, and I can say the thinnest rib that I want is 0.125. The most thick rib could be 0.375. And it can range to any value in between these numbers. I'll add another variable, base thickness. Again, I can choose a range of values. I can do my minimum as 0.125, my max is 0.375. I agree with both those numbers. Let's go with rib number. Now this time, I can't just go to any value, I need to have whole numbers. You can't have 2.5 ribs as your minimum, so I'm going to specify 3 ribs as my minimum, 8 is my maximum, and we're going to step 1 rib at a time. And that way we don't have any decimals for ribs. So this will step from 3, 4, 5, 6, 7, 8, of course in increments of 1. If I were to specify 2, then it should step 3, 5, 7, and 9 if we didn't have an 8 there. Let's add another parameter, and that's going to be the rib angle. Again, I can use that as a range, and we can range it from 10 degrees to 65 degrees, anywhere between there, or whatever parameter I wish to set. Looks like we're fully defined now. That the biggest thing is I don't want to have any features that are smaller than my mesh. The max size of my mesh is 0.1, my minimum feature thickness is 0.125, so we should be covered there. I'm going to add some constraints now. We want to constrain this with a sensor, and the sensor would be our simulation data, and we want to make sure that our stress does not exceed the yield stress of our part. I'm going to do this, of course you would want to do this with the safety factor, so you do not approach elastic limits in your material. I'm going to specify stress must be less than, and Newton per millimeter squared of course is a megapascal, so we're going to say 50, which is probably around the yield stress of megapascals, or yield stress of ABS, the material that we're using. So this is a very simple analysis. You'd want to have a formal safety factor when you're doing this as part of an engineering project. Finally, we want to make a goal to minimize our mass. Mass comes up immediately. So mass 1, minimize mass of our part. You can add multiple goals if you want to as well, but this is good for the study that I'm doing. With the optimization box checked, I'm going to click on Run. This could be quite a long time to run, so be patient and let this thing do its thing. Okay, with this simulation done, you can see it's delivered us an optimal configuration for what we've put in, and that's going to be low base thickness, low rib number, low rib angle, and a high rib thickness. These are all the different configurations that SolidWorks has simulated. Interestingly, none of them failed, which means that I could have typed in a much higher number of force. And you can, of course, activate by clicking on every iteration that SolidWorks has tried. Once you get this basic view or configuration that's optimal, you can change the parameters to be a little bit more specific. So I could try to do my ribs from 3 to 5 and specify less thickness settings and everything else to fine-tune an even higher optimal thickness. But that is how you would do a design study, and a great way to optimize parts in ways that would take forever to try to analyze by hand. Hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.